Hi everyone, welcome back to our channel. So today we are going to find the solution for find the equivalent resistance across the terminal X and Y. So whenever we are solving the problem from this side, we need to solve from the opposite direction. Whenever you see this problem, you can understand that these two resistors are connected in parallel. Okay, so these two are connected in. Why? Because current is dividing, these two are going to connect in parallel. So now I'm going to redraw. So we are going to have a 5 ohm resistor, and we are going to have a 2 ohm resistor, and these two are connected in parallel across the node A as well as across the node C. We are going to get one single resistor. So 2 into 2. Okay. So 2 into 2 divided by 2 plus 2, which is nothing but 1 ohm. And again here we are going to have a 1 ohm resistor. And whenever you see here, the current flows and the current goes into this 1 ohm, and the same current also flows in the 1 ohm. I can say these two are again connected in series connection. Therefore, between the node X and Y, so this is node X, this is node Y, we are going to get a 5 ohm resistor with an 2 ohm resistor, and these two are connected in series between the node A as well as node Y. Okay, so between node A and Y, we are going to have one more resistor. So to 1 plus 1 is how much? 2 ohm. And you can see here the current enters and current is going to divide. Again, these two are again connected in parallel. So whenever they are connected in parallel, so we are going to have a 5 ohm resistor connected across X, connected across Y, connected across A, and connected across Y. So whenever two are connected, the formula is product of resistance divided by sum of resistors. Okay. So therefore, when you solve it, you can see here this is a 5 ohm resistor, and this is an another resistor. This is 5 ohm resistor, and automatically you are going to get 1 ohm. And again you can see here the current flows across the node X, across the node Y. The current flows in 5 ohm, and the same current flows in 1 ohm. I can say these two are again connected in series connection. So therefore, across the node X and Y, we are going to have a single resistor where this is nothing but 5 plus 1, which is equal to 6 ohm. So this is the procedure of solving. I repeat the procedure, those who are unable to understand. These two are connected in parallel. I have got one resistor. Again, I had got this resistor. These two are connected in series connection. I have got 2 ohm resistor. Again, 2 ohm and 2 ohm are again connected in parallel. I have got a single resistor. Okay, so again this 5 and 2 are connected in series connection. I have been obtained one resistor. So this is the procedure of solving the problem. Hope if you understand my method of solving, please like the video, and the students, those who are studying like you, please share to your friends. And if you are watching the channel for the subs time, please subscribe the channel. If you have any doubts, let me know in the comment section. So to subscribe, the channel name is KV Tulasi Ram. This is, please kindly support this type of channel. This is a free channel for the development of students and faculty. So thank you for watching. We'll meet in the next video. Yours Ram.